Imagine this, capturing the world around you, not just environments, but objects of all shapes and sizes, and transforming them into 3D models that you can use directly in your designs. That's the magic of photogrammetry and point cloud technology, and guess what? They're more accessible than you might think. You can do this with a tool that's already in your pocket, your smartphone. This video is going to dive deep into the Vectorworks Nomad app, a powerful tool that unlocks the potential of mobile 3D capture within the Vectorworks ecosystem. Nomad allows you to capture environments and objects and transform them into highly detailed 3D models, all within the familiar Vectorworks interface. Hi everyone, my name is Tony Kostreski. I'm a landscape architect and senior landscape product specialist at Vectorworks, and I've been exploring the potential of these technologies to enhance our design processes and outcomes within the landscape industry. Now, while this video focuses on applications in landscape design, the principles and technologies we'll explore hold immense value for a wide range of design disciplines. So, whether you're an architect, an interior designer, a theater designer, or work in any creative field, Nomad can be a powerful companion. Throughout this session, we'll delve into the fundamentals of photogrammetry and point clouds, along with practical tips and best practices to maximize the potential of Nomad within your design process. This session caters to designers of all experience levels, offering valuable insights to elevate your creative projects. Are you ready to dive in? Subscribe to our channel and join me on this informative exploration. Let's begin. So let's go over what photogrammetry is and what point clouds are. Photogrammetry is a method that uses photographs or images to create 3D models of objects or spaces. It works by taking multiple pictures from different angles and using those pictures to calculate the shape and measurements of the subject. Point clouds, on the other hand, are like digital representations of the real world in 3 dimensions. They are collections of thousands or sometimes even millions of individual points, each with X, Y, and Z coordinates that together create a detailed and accurate model of an object or an environment. They are produced using technology called LiDAR, light detection and ranging, which involves sending out laser beams and measuring how long it takes for the light to bounce back after hitting an object. By doing this millions of times per second, LiDAR can capture the precise distances to objects in its path. Now, the size of the project will determine which tools are best suited for the job. For a large site, it might make sense to invest in a drone to capture aerial imagery, which can be used to create ortho images or to generate 3D models with photogrammetry. If more precision is required, some drones can even be equipped with LiDAR scanners. The possibilities with this technology are truly incredible, but there are still limitations like obstacles on site that might make it difficult to capture anything, or restricted airspace over landmarks, aka no-fly zones. And there might just be instances where drone usage just doesn't make sense. So instead, we are going to see how the Vectorworks Nomad app can fill those gaps so that you can still leverage this technology on your future projects. So what is Vectorworks Nomad? It's a mobile app you can install on either your smartphone or tablet, and it's part of the Vectorworks Cloud Services platform, which also includes a desktop app and web portal. With the Vectorworks Nomad app, you can take photos and transform them into 3D models, and on LiDAR-equipped iOS devices, you can utilize sensors to generate point clouds. The photographs, generated 3D models, and point clouds captured on the mobile or tablet device are conveniently accessible on both the desktop app and the web portal, thanks to its bidirectional syncing capabilities, making them immediately available to import into your Vectorworks model. The desktop app and the web portal also allow you to upload photographs taken elsewhere and generate 3D models with the Photos to 3D Model command. You can also integrate the Vectorworks Cloud with Dropbox, Google Drive, and OneDrive for extra space. There are many other features included in all these apps that I also encourage you to explore. For instance, with the Nomad app, you can view and mark up PDFs, view Vectorworks models in augmented and virtual reality, and you can measure spaces in augmented reality. You can also view Vectorworks files on the web portal and share them with clients and contractors via a web link or a QR code. So let's look at different types of objects you can capture with your mobile or tablet device using Nomad. For photogrammetry, this includes objects you can easily walk around like boulders, rocks, tree trunks, some plants, sculptures or art installations, garden furniture, retaining walls, building facades or structures, and even entourage elements like people that provide a sense of scale to your digital models. For point clouds, this includes smaller sites that you can walk around in 10 to 20 minutes and are not easily accessible by a drone. Perhaps a residential site like you see here, or a small park, or a hillside, or maybe even a wooded area seeking a proposed path or boardwalk. Alright, let's get started. After you get the Nomad app installed on either your smartphone or your tablet, tap Files from the toolbar to select the folder, or tap the plus icon and create a new folder where you would like to place your photos. Click the plus icon one more time, then tap Photos to 3D Model. You can review useful tips before scanning by tapping the question mark on the top right. For instance, optimal days for scanning outdoors are on cloudy days without any harsh shadows. And then for photography tips, make sure to have 70% overlap between adjacent shots, keep the object in frame, and depending on the subject, you want to capture between 20 and 200 photos. You want to capture all sides of the object, and then just know that any objects that are reflective, transparent, or have thin structures like tiny little branches, they're not going to get captured well. Tap the Info button to see if your device supports gathering gravity info from the device's internal gyroscope and depth from the device's camera, which is used by the cloud job to reconstruct the object in its actual orientation and scale. And now you can begin taking photos. For an object like this planter, I recommend taking between 40 and 80 photos for best results. And again, you want to make sure that you're taking photos from all angles, including from above. When you're finished, tap Done. You can either submit the task now or tap on Submit Later if you need to capture other objects on site. The photos are uploaded to the selected folder along with an associative depth photo and gravity text file if your device supports those features. You can select all of the files in the folder and tap on the Photos to 3D Model icon. Select the available export options for detail of output, model feature sensitivity, and object mask. You can also select where you want to save the output files, and then you can select Done. Once complete, both a USDZ file and an OBJ file with material and texture files are created. The USDZ file can be used for previewing the model in 3D or in augmented reality on your iOS Nomad, or for other purposes and other applications that support this file format. The OBJ file can be imported into Vectorworks as a mesh, and that's what I'm going to recommend that you import into Vectorworks. So to do that, you can either go to File, Import, and select Import OBJ, or from the File Explorer or a Finder on a Mac, you can select the OBJ file and just drag it directly into the design layer space. Now because I'm on a Mac, I can actually tap on the space bar and preview the 3D model before actually importing it. So let's go ahead and drag and drop the OBJ file directly into the workspace. And for the import OBJ options, we want to make sure that we select import materials and that we also have a checkbox for import transparency and image data as RenderWorks textures so that we get the texture on the mesh. And then for devices that did produce a gravity text file and also a depth image, we can import it to scale. Now for Nomad scanned objects with photogrammetry, the unit tends to be meters. So let's go ahead and select meters for our units and then go ahead and import. Once the file is imported, we can see that we have the mesh, and if we actually switch over to a multi-view pane, we will notice that the orientation is actually incorrect. And that's just simply because the Z and the Y axis are flipped on the app versus how Vectorworks reads it. But that's not an issue. You can use multi-view to easily rotate it, but what I recommend, the very first thing you should do is just go to Modify, Rotate 3D, and then select the X-plane for the working plane and rotate it 90 degrees. And just like that, you'll have a correctly oriented model. Now let's just switch back to one view. We'll deactivate the multi-view. And what I'm going to recommend whenever you import an OBJ mesh, that make sure that you're using the orthogonal view mode. It's going to make it so much easier to edit, to reorient, to scale. You're going to see that in another example. But first, let's go back to the output settings and see what the different levels of detail for the output look like and how it affects the model that's imported. Now in this example, we generated a 3D model with every detail level so that you don't have to. On the far left, we have raw and high, and as we go down to the right, we go down in levels of detail from full, medium, reduced, and preview. The first thing you're going to notice is that the file size goes from 86.1 megabytes all the way down to 2.3 megabytes. And also, the number of faces greatly reduces from left to right. For raw and high, we see a whopping 791,886 faces. And as we move to the right, we see the number of faces greatly reduce. Now, what does that mean? That means that the quality is also going to diminish. So depending on the object, you might want to select a different level of detail. Especially for something like a plant like this, you'll notice that the higher we go, the more detail we get around the plant in the center. And then for object mask, let's take a look at an example here. We have a boulder on site that we might want to reuse and move right on site. With the object mask unchecked, we get the surrounding elements. With it checked, you'll see that it actually does a really good job at automatically just eliminating everything around it. But let's take a look at an example where we know we're going to want to clean up the mesh. So my brother has a house in Ogden, Utah, and he wants to add a second-story deck to the back of the house. So this is an example of bringing in the facade of a building and using that as a background. Now, he didn't have an iPhone, so there's no gravity text file or depth image to associate the scale of this project. It's just taken with a regular camera. But ultimately, it does create the OBJ file that we can preview, and we'll import this. This is an example where we might want to get rid of the trees and maybe even the ground. All we want to keep is the facade of the house. So to do that, we'll drag the OBJ file directly into Vectorworks. Make sure that the checkbox for import materials and the textures is still selected. The units doesn't really matter because this isn't going to be to scale since there's no gravity text and there's no depth photo associated with it. Once it's imported, we can select Fit to Objects, and I like to always switch over to an orthogonal view. Now I know that it's going to be oriented incorrectly. If I move around this project, it just looks like it's totally flipped up. So how do we orient this appropriately? So we're going to look at this from a top view, and with every OBJ file that I import, at least from Nomad, I find it best to go to Modify, Rotate, Rotate 3D, just like we saw earlier. Type in 90 degrees for the rotation angle and select the X plane. That's going to be the first step. The next step is to rotate the face of the building so that the front is facing downward. Let's use the Rotate tool, and I'll select both sides, both corners of the building, and rotate it like so. We can select Fit to Objects again, and now we can either select the front view, we could use the number pad, which makes it a lot easier. I can tap on the number 6 for instance. That will give me a right elevation, 9 will give me a back isometric view, 8 will show me the back of the house, 7, 4, you get the idea. So 2 is going to be front of the house. Now how do we delete these faces for the mesh object? Well, we can use the Select tool, and we can either use the rectangular, lasso, or polygonal marquee modes to actually delete the faces. So with rectangular, it's just going to have you draw a rectangle, and then you can just go ahead and tap on the delete key. Just like that, you can start deleting faces. I like using the lasso tool because it allows me to draw around very specific faces so that I can go ahead and just delete those. Once we're satisfied with the front of the house, we can move over to an elevation view. And you can see that there's this floating geometry that we just want to delete, and same with the ground. So I'll keep the stairs And I don't think we need any of this information as well, so we can just go ahead and delete that. So now we are left with just the facade of the building, and we can start putting our design around it, at least after we scale it appropriately. So I do have the measurement from left to right of the building, and that's 62 feet. So with the mesh selected, we can go to Modify, Scale Objects. I like using the second mode, Symmetric by Distance. We can tap on this button here for current distance. We can zoom in with the Z key and go all the way to the other side and just type in 62 feet. Now that I know that we're appropriately scaled, we can now add a deck. Of course, I'm just using this for preliminary ideas. When we do the actual design and installation, we're going to want to get true measurements. But at least for this, we can start off with some conceptual designs. I can switch over to the line tool, for instance, just to scale, check the door frame here, which I know is 6 foot 8 inches, so we're pretty close. Let's switch back to this boulder example. Although this looks really good in 3D, it does not look so good from a top plan view. We're seeing all the different faces, and that's probably not what we want to show on our drawings. Instead, we might want to actually show what we call a hybrid symbol, having a different 2D representation for the 3D. It's essentially combining 2D line work with a 3D object and combining it so that it's just one object. So because I already have this geometry here, I can copy that. And what we'll do is we'll select the mesh, go to Modify, Create Symbol. We can give it a name. In this case, I'll just call it a boulder. And for insertion point, at least for this object, I'm going to select the projection center of the mesh. Once we have a 3D symbol, we can double click it and go into the 2D components. Now there is a trick here to right click and select Generate 2D from 3D component, but because there are a lot of faces, it might take a while to process. Instead, just tracing it will probably be a lot faster. I'm just going to paste this line work that I've already drawn and show you how this works. Essentially, there are two objects. There's the front of the object and the back of the object. And the back of the object has a thicker line work, just for hierarchy. And then in between, we just have lines, just to give it at least a graphic style that I like. As soon as we click Exit, it's going to ask if we want that to become a hybrid symbol. I'm going to select Yes. And now we've successfully converted this into a hybrid symbol so that we have both a 3D representation and a 2D representation. Now I hope that gives you enough information on starting to think about which objects you might want to scan out on a site, whether they're plants. Now again, with plants, not all of them are going to scan well. Objects like hostas, especially if they're standalone objects, they actually scan quite well, like you see here. Hydrangeas in the distance as well. Boulders, of course, do a phenomenal job. Other objects you might want to consider are trunks of trees, especially if they're ones that are going to exist on the site that you want to showcase in your digital model. And then, of course, people. So I have myself scanned in a variety of different positions just to add a sense of scale to the digital models. Now, whenever you create objects that you know you are going to reuse on different projects, make sure you turn those into symbols and store them in the resource manager so that you can reuse them. So again, I have myself and my colleague Luis here in the resource manager. There's also all the boulders that I'm working on, as well as the plant symbols that I have in the foreground. And with that, let's move on to point clouds. Now I'm going to be using an iPad Pro and an iPhone 14 Pro for today's scans. The LiDAR point cloud scanner is supported on all LiDAR-enabled iPhone and iPad Pro models, and the LiDAR sensor is going to work at a range of up to 5 meters, so just be aware of that before you start scanning. Also, the accuracy of the point cloud is really going to depend on the size of the scanned object in the environment. For instance, a large campus site that you're trying to scan is not going to be as accurate as a courtyard or a residential space or a small park. And that's simply because the farther you get from the origin, you start seeing this drifting behavior within the point cloud. Also, a completely empty space, like an empty field with just grass, is not going to be as accurate as a space that has more geometry to scan, like walls or different textures on the ground, like grass versus mulch, or plants, fences, and structures like buildings. So if there's more geometry, you're just going to have a much better time and have a much more accurate model. So let's get started with the first site. We're going to be scanning this residential site that we see here. And remember, the Nomad app is going to be a companion for your site inventory. I still highly recommend taking your photographs, become very familiar with the site, walk the entire site before you start scanning. You want to actually plan out a mission. Just like you would with a drone, you're going to plan your mission, you're going to see where you're going to walk, mainly because of safety concerns, of course, right? And then, of course, you still want to take measurements. Now, the point cloud will be pretty accurate, but it's important that you still have something to reference after you import the point cloud, just to double check. So let's look at the property plat. Now, a site this small, you can probably get away with scanning it all in one go, or you might consider breaking it up into different scans. Maybe in this property, you actually break it up into 3 different scans: the backyard, the side yard, and then the third scan will be the front. Similar to what we saw with photos to 3D, the best practice would be to create a new folder or select an existing one to place the point cloud scan. Tap on the plus button, then tap LiDAR point cloud. To start, tap on the play button on the right side, and you're going to want to wave your iPhone or iPad in circular motions. Yes, I know it's going to look like you're trying to get a signal, but the more circular motions you make, the more points you'll capture. At any point, you can use the blue slider on the bottom of the screen to dim the camera to see if there are any missing areas that need to be scanned. And for comparison, here's the iPad and iPhone side by side performing the exact same scan. When you are finished, tap the Save button to stop scanning and save the point cloud. 2 point cloud files are going to be created. Import the file with the VW suffix into Vectorworks for proper orientation of the model. And within Nomad, you can view the file without the Vectorworks suffix, and you can orbit around and navigate and see if the point cloud capture is what you need or if you need to perform another one. Now for the exciting part, what you can do with point cloud files within Vectorworks. So similar to the last process, you can go to File, Import, and select Import Point Cloud, or you can go to the Finder and look for the point cloud file that has the VW suffix. This one will have the Z-axis properly oriented so that you don't have to rotate it. Next, we can drag it and drop it into the workspace, and then we can select the percentage of points to import. In this case, I'm going to do all 100% of them. And then for the units, I'm going to select millimeters, and this is going to import it to scale. The first thing I like to do is actually switch from a 2D plan view to an orthogonal view. This is going to give me much more clarity at what I'm looking at, and it's an opportunity for me to reorient the point cloud. For instance, I might want the back of the house to actually align with the x-axis. Once I do that, I can actually use the number pad now to view the point cloud file from different isometric views. I can also use the number pad to view it from different elevations. And right now I can tell that it's sloping away from the house. So very quickly I'm getting an understanding of what's happening here. I can also see that there's a tree trunk here. I can look at the vegetation. From a top plan view, I can actually make out where all the hardscape is versus the planted material. So let's take a look at the other point cloud scans I got. Now I did a total of 5 scans. With the iPhone, I scanned both the front and back all together in just one scan. It took roughly 15 minutes to walk the entire site. I did another iPhone scan of just the back, and then with the iPad I actually did 3 separate scans. One of the back, one of the side, and then one of the front, just to see which method was going to be most successful. And then just for comparison, I imported the iPad scan of the back and imported it with 1% of the points and 100% of the points, just to show the difference in quality. So clearly the 100% of the points is going to be much more useful in this case. So let's take a look at what we can do with the point cloud. If you opted to take multiple scans on a site, I'll show you how you can combine those together by aligning them, merging them, and ultimately creating one point cloud out of those. So the first thing I'm going to suggest, at least in this instance, we have 3 different point cloud scans. We have one of the front, the side, and the back. We want to find similarities of geometry between them so that we have something to help us align them together. Now the side of the house has some really good corners of the building, so we're actually going to use this as basically our foundation. For these other ones, what we can ultimately do is actually remove points, so it's a lot easier to align the 3 point clouds together. So let's start with the top one. We'll select it, go to the Object Info palette, select Isolate Points, and you'll get this mode bar at the top where you can either remove points, add points that you have already removed, or find an intersection of points. I'm going to use this rectangular mode, and I'm going to select a rectangle around these points right to the edge of the wall. And that's going to help clean it up. I'm going to do the exact same thing with this one on the side. And I'm going to remove the points all the way up to the wall. That's just going to make it so much easier to find an alignment when we look at this in an elevation. Let's do the same thing below. And I'll remove these points right here. So if we kind of fast forward and we go to align, we now have the ability of seeing where these models are going to align best. So the edge of the wall to the edge of the wall. We can also fine-tune this to meet the ground. Right. That looks about right. And then we have this one of the front, which I'll just bring in and snap. Then in the top plan view, we can also align these. So I'll grab the side, and I know this is going to align right about here. Remember, we're creating a reference of the space to at least get started on our schematic design. And the bottom actually looks quite good. So now we have the point clouds aligned. After you finish isolating the points, what you're going to want to do, and I'll just back up to this one right here, is you're going to want to make sure that you select Delete Isolation, and that's going to delete the points that are outside. You're going to have to do that before you do the final step, which is selecting all of the point clouds, going to Model, Point Clouds, and selecting Merge Point Cloud. Once we do that, we'll be left with one single point cloud. And once we have that, we can start making use of the clip cube, which can be found at the top. If you don't see it right away, you can add it by making sure that Show Clip Cube is checked. And then we can temporarily clip away different parts of the model. So this helps us really understand what's the lowest point of the site. It helps us visualize the building as well, all the different structures actually. And then we can actually pull sections. So this is very useful if we wanted to view this from the side. We can actually reduce the size of this on both sides and look at elevations and very quickly get an understanding of it. At any point, you can right-click on a face and select Create Section Viewport. So I already have done this on all the different elevations. So we have one of the plan view, we have the right elevation, front elevation, back elevation, and also left elevation. Let me just turn off the background. And this is what we can actually plot out. So we essentially have sections without actually drawing anything yet. And once we have this in place, we can start tracing the different geometry to start creating our existing conditions plan. And it really isn't that much different than using regular trace paper. We're just going to be tracing in 3D, using the point cloud as a reference. A couple other tips that I found along the way is that if you do not like this white line, this white outline that you get on point clouds, you can actually select it and just turn off the pen. Like that, it will remove that line when you see it in both the top plan view, but also when you cut sections through it. And then in 3D, you've probably noticed this already, I have this dark background mode selected on. You can find it under the drop down if you don't have it activated. And it's basically an on and off switch. Whenever I'm working with point cloud files, it just makes it a whole lot easier to view the point cloud file. If you want even a greater contrast, you can actually create a Renderworks background. In this case, I'll create one that's just labeled dark background. And for the color, instead of 2, I'll just pick 1, and I'll just make it black and drag that into the scene. And that's just going to enhance the contrast between the point cloud and the background, of course. So with this point cloud, we can actually generate a site model. You can certainly right-click and select Extract 3D Loci, but I found that I do not like this method because you don't have control over which loci is actually being extracted. You'll get some in the tree, on the structures, the fence, the building. You get the idea, and it's just a pain to generate a site model. Instead, what I'll do is I'll switch over to a multi-view. I have top plan on the left, and then on this 3D view, we can actually start placing spot elevations. We want to make sure that our show snap is on and also that our snap palette is also activated. I have a design layer here now where I can place stake objects. And for my stake objects, I'm going to use the mode include as site model data. So what this is going to allow me to do is navigate in 3D, and I'm using a space mouse if you're wondering how I'm flying around. And I can actually drop in spot elevations quite easily. Now I set the first floor elevation of this building at 0 so that I can get proper stake objects based on that. Now we want to watch out for the dog here, but I think corners of buildings, bottom of stairs are going to be quite useful for this. I know there are steps along the side, and we can work our way around, get some in the front as well. And I'll just fast forward to the source data that's been created here. And you'll see that I've created roughly 93 of them. Let's switch back to just a single view. And we can use those spot elevations now to generate a site model. Now, because this site isn't that large, I'm going to use 6 inches for my contour level so that I can get a good understanding of the site. Of course, this is going to be an estimate. It's not going to replace a surveyor or a total station, but it will give me a pretty good idea of the site. For instance, I now know that it's sloping from the front of the yard all the way to the back. We can use things like colored elevation to get a sense of what's high and what's low. So, like that, we have a site model. Next, let's start tracing all of the different surfaces. The steps I like to do here are to, well, first turn off the site model and activate the clip cube. And I'm going to bring the top plane of the clip cube down just above the surface. This is going to give me more defined lines of different structures, the fence, and yeah, so just above the surface. We can then switch to orthogonal view and go to a top view, not top plan, and we can see the building much more defined along with the shed structures that we see over here. So I start off with basically the entire property, start off with that, and then I'll trace the buildings, the hardscape, and then the rest is essentially softscape. So we'll fast forward here. And then I'll go ahead and turn off the design layer for the point cloud so we can see the surfaces that I've traced. So these are all totally flat. If we see it with the point cloud turned on, we can see that we have the building structure, the shed structures, the stairs. Basically, the entire property has been covered with simple geometry. And then we can use these and convert those into smart objects. Now, you probably don't need to get this detail for an existing conditions plan, but maybe you want to pull volume quantities of hardscapes that are being removed, or maybe existing plant medium. Regardless, here are the steps to convert these to smart objects. Red is going to be representing my existing structures, including stairs. Orange is representing hardscapes on the site, and the teal is representing existing softscape, or basically just dirt. So what I can do is go ahead and select all of the similar colored shapes, in this case all the teal. I can convert these to landscape areas, for instance. And then I can do the exact same thing with all of the orange. I can convert these to existing hardscape as well. If I know what the buildup is, I could pull volume quantities of all the different materials. I'm just going to turn this into a brick paving herringbone, and we can actually have these drape to the site model that we created. So let's go ahead and select that. This will cause all of the hardscapes to actually map to the site model that we have here. Let me just click update so that we can see that that cuts it. And then we can actually tell all of the landscape areas to follow the terrain as well, simply by going into the object info palette and telling it to listen to the design layer that the site model lives on. And like that, we very quickly generated a site model with some of the existing materials that are on site. Now, I picked brick for basically everything, but you can always go back in and fine tune it. For instance, I know this is actually a different style, which I created here, some existing concrete pavers. And this one over here, and also at the front of the house, we actually have concrete there. So I can replace those as well through the object info palette or even through the resource manager. So just like that, we applied different textures there. Oh, let's just do one more. So we have the driveway, that's just gravel. So we can pick gravel. So now we have the surfaces. Let's take a look at the building. Depending on how detailed you want to get, you can either convert these to a simple massing model with a roof structure. So in this case, maybe it's 10 feet tall and just one floor. You can use roof from profile to get a generic shape for the massing model, or let's just undo. We can get very detailed with this and actually make use of tools like the walls and apply the siding that you see here. This is where it's going to make sense to turn the point cloud back on to make sure that you reach the roof lines and all of that. Now let's fast forward actually to what I have over here. And basically what I've done is I've made use of the point cloud to align my windows, to align my door, and also from different elevations you can see that we have the windows lining up with the point cloud. It was very, very useful to have the point cloud to give me a representation of what I needed to generate the full model. And we can use those same techniques to model the shed structure that's in the back, as well as the fence that wraps around the property. Next, let's take a look at adding any of the existing vegetation. Now the point cloud is really going to help out with this next part on placing existing vegetation. Let me go ahead and turn everything else off. We can certainly see existing tree trunks off to the side on the property. But if we want to better visualize this, we can actually make use of the color scale found in the object info palette when a point cloud object is selected. So we can actually use grayscale. This is going to provide a nice contrast of anything that's off the ground. If we look at this from a top view, we can very easily see the boxwoods here at the front that are overgrown, the crepe myrtle, and if we go down here to the backyard, we can also see the boxwoods that are surrounding the paving here, and also some arborvitae off to the side. And it looks like we have maybe some hydrangeas over here. So there is the grayscale, which is useful. That's the one I like to use. You can play around with these other ones like cyan, similar idea. Rainbow's pretty cool to use because that's going to create some nice contrast between different vertical elements. We can see the building here showing a nice green. It can even get warmer at the top. This is actually typically how I perceive LiDAR point clouds. And then there's this last mode where you can set a custom color. So you could either use 2 regions or 3. I like to use 3 sometimes. And then you can apply a color to each one and set very specific elevations. So for instance, I can reduce this down to 1 foot and maybe region 2 down to 4 feet. And we can click preview before actually committing. And you can change this as you move around. So again, we can go back to 2 feet and maybe 6 feet. I think that's what we started with. We can move it up a little more, 8 feet, 4 feet. And you'll see that this is going to help us visualize where the plants are just a little better. So after we make use of this and we place all of our plants, we'll fast forward to that. And that will include the understory vegetation as well as the upper story vegetation. At this point, we now have everything modeled on our existing file. And this will be a nice representation of all of the existing plants that we have on site. So we have a nice inventory of ones we might want to transplant or hardscaping materials we might want to reuse. And just to kind of go back in time, we went from this point cloud file of this elevation all the way to this fully 3D modeled representation of the existing site. One other consideration is potentially adding the surrounding context. So I actually did that by georeferencing the file. And I brought in a base map, and I also brought in feature layers from ArcGIS Online. Now that's a whole different topic. I encourage you to look at that. But it might be helpful to be able to see the surrounding context when making design decisions. And also for discussing ways you might be able to access the site. This luckily has access on both ends from the alley and also the main road. Once we have this full 3D model along with the surrounding context, we can actually place Heliodon. And again, because this is georeferenced, I can simply select the checkbox to determine the location. And then we can run solar animations. We can either use this slider to interactively check out the sunshade. We can also look at a very particular time throughout the entire year. Or we can actually export a movie, and we can select either to animate the time or animate the day. And remember, you can actually process this on the Vectorworks cloud so that you can continue working away. So let's take a look at a couple of those. On the left, we have a solar animation of a particular day from sunrise to sunset, and on the right, we have a time seen throughout the entire year. Back to the existing model, there's one thing I did want to point out. This existing crepe myrtle happens to be a 3D model that was generated from Nomad. So I took a series of photos of the existing trunk because I wanted to retain as much of the existing character of this tree as possible, since I know it's one of the few plants that we will be keeping. A lot of the other plants are just overgrown and taking away from the character of the historic home, and a lot of the understory plants here aren't doing so well. So this is pretty much ready to start adding the design. Let's go to the back. There's a couple other objects that were scanned. For instance, the planter, which you saw earlier, in case we want to reuse this nice planter. And yeah, no, just the hostas. There was an attempt at doing an object capture of the back of the house. I can actually show that to you, though it was quite difficult to get enough photos to generate a quality 3D model. So, I mean, of course, the stairs I was able to capture pretty well, but the architecture not so much. Well, anyways, that is everything that I have for this particular site. It is ready to be designed. I'll be working on this afterwards. Let's take a look at a couple different point cloud examples. In this next example, we'll take a look at a neighborhood park that might be working with a lower budget. Being able to capture an entire point cloud with your smartphone to then produce a site inventory is going to be incredibly useful. So as a recap, what can we do with this point cloud file? We can run the clipcube command and analyze it, cut sections. We could also do it from top to bottom to understand what's the high point and what's the low point. So this is a nice visual cue. We can also select the point cloud and use the color scale. We could view it in grayscale to look at different elements on the site. Rainbow. And then we'll go back to original. We can place stake objects along the point cloud file and then ultimately generate a site model. So let's just kind of fast forward. All the little orange dots that you see there, or in top plan view, these are all the spot elevations. Ultimately, that will create a site model. And let's just go ahead and turn off the point cloud. And we have the existing surfaces traced as well. And really it's just the brick. And the only reason I did that is it might be nice to have it, the total area of the existing brick. Maybe we can reuse some of the material. Next we can add the fence, and then last the vegetation. If you really want to georeference the project, you can, and that will allow you to add other information like parcels and buildings if you have access to those feature layers. So that's an example of being able to produce another type of existing digital model. Let's look at a couple other examples. In these next examples, I just wanted to do some tests on walking through some woodlands. Now, of course, these are already existing pathways, but I just wanted to see how it would work going in and out of trees, and I thought it did a pretty good job. So there might be a use case in being able to explore using this for plotting out potential paths. This other one over here is quite a long path. It actually has stairs in it, and I wanted to do a test on creating a site model from it and extracting grades, which it actually does a pretty good job at doing that. In this case, I did use the extract 3D loci, and I just deleted the loci that were on the trunks. And then on this last example, this is also a path that leads into a boardwalk. So this is kind of the idea where I thought the LiDAR might actually be a nice companion when you're exploring some ideas that are navigating through a series of woodland trunks. Okay, let's look at one last example for creating an as-built record. This example was designed and built by my colleague Brian. He also happens to be the landmark trainer. Now, Vectorworks was used very conceptually to visualize proposed driveways, additions to the house, plant bed areas, patio, and also an outdoor kitchen space with a fireplace. And lastly, an outdoor shed. So after the project was built, Brian was able to use his mobile device to actually capture a point cloud scan, and this can be used as an as-built record. So let's go ahead and turn everything else off and take a look at what we have here. So we have the driveway going all the way to the road. We can see the plants. We can see that there was a rain harvesting barrel added here. We can see all the plants. We can see the perimeter of the patio. We have a nice visual of the outdoor kitchen that was installed, the fireplace, and also an egress window. So we can view this from a top view. Again, I always recommend viewing this in orthogonal. It's going to make it a lot clearer to visualize. And in this example, the point clouds were actually scanned in 3 different sessions, which you can always go back into model, point clouds, and then merge these 3 point clouds together. Once that's done, if we wanted to visualize this with the grayscale, we can, or with the rainbow. I'm just going to go ahead and change that back. But consider using the LiDAR scanner as a way of taking essentially a 3-dimensional photo of your completed work so that you have a record of it if you ever need to go back, make some changes, or just keep a record of it in general. Well, that's a wrap. Thank you for joining me on this exploration of photogrammetry, point clouds, and the exciting world of mobile 3D capture. I encourage you to embrace this technology experiment, and discover new ways to enhance your design processes. For more design inspiration and valuable tips, subscribe to our channel. And feel free to connect with me on LinkedIn and share with me your Nomad experiences, because I'm always eager to hear from fellow designers. Happy creating, and see you next time. Bye for now.